Hey, hello, welcome back. It is John Park's Workshop, and it's me, John Park. And it's been a little while because we've had some weird shows in the last month or so. The Ask a John Park's Workshop when the Adafruit move was happening, followed by CircuitPython Day. I think this is the first normal one. Neat. Thanks for joining. The party is right here in this room. And by this room, I mean the Discord chat. At least that's what they're saying over there. And of course, also over in our YouTube chat. So thanks for stopping by. Dave Odessa, Garrett Trailer, Ludovic Bouet, Andrew Famsworth, Connor McCarter. I hope I'm getting everyone's names right. Thanks for stopping by the YouTube. If you're wondering where the chat is and you're over in Twitch or Facebook or somewhere like that, then check out our Discord. It's at adafruit.it/discord. You can look for the live broadcast chat channel right there. That is it. And hello to Some Nice and Andy Calloway, Paul Cutler, Todd Bott, Starman, Thin Man. Hello. And thanks for joining. What else? What's happening? So, hi, Uniscu7. Yes, Type-C power delivery. That's right. That's going to be the project topic for today. I'm going to show you some progress I've had on that. I worked on that a little bit for CircuitPython Day, and I've added to it. I've just sort of spruced up the interface a bit, built a couple of prototype 3D printed cases for it. I'm going to talk about that process a little bit today, too. And I have a neat retro thingy, which you may have seen on Show and Tell yesterday. I brought on this cool terminal over here, the VT100. So we'll talk about that a little as I look into restoring it. Also, hello Keith Schlotthauer, who just joined over in YouTube. Thanks for stopping by. Since I wanted to actually start opening up some suggestions and questions and topics for future shows, I have a pencil. Let me get a sharper pencil. I have a pencil on hand, and I saw a good one over in the YouTube chat. It was Andrew Farnsworth who said, if you're taking suggestions on future topics, I am. I'd love to see something using LoRa and or LoRaWAN. Excellent. I like that. And in fact, I just got back interested in LoRa recently because someone gave me a couple of Meshtastic, I think, Meshtastic gizmos, which is a interesting, I think, open source project that uses LoRa gizmos to allow long-range communication among devices. So you Bluetooth to the little LoRa gizmo, and then it uses the Meshtastic mesh of LoRa devices to hop messages around and then appear on another one, which can then in turn talk to a Bluetooth connected device such as another phone or computer. So I'd like to dig into that a little. I have those two gizmos. I forgot to bring them into the workshop. They're in the house, but I'll bring those in and maybe talk about getting some of that working on some Adafruit feathers, possibly. Let's see, other topics. I have existing security cameras and the control box is down. Is there a way I can patch into a solo camera? Perplexing. I'm not sure I follow the details of that Garrett trailer, but if you want to post some more details about that there. Or, by the way, I'll say, the Discord is a good place to ask questions, especially in some of the help channels. There's general chat, but then there's help with, if you can narrow it down to a topic. We've got CircuitPython, 3D printing, Arduino, audio, Git, hardware design, projects. That's a good general one. Radio. So ask as well there. But if you have questions, this is a good place to post them. What else? Love to see a tutorial on fast LED and a trinket with a push button, setting up patterns. Okay, I like that. That sounds doable. Fast LED plus trinket and button. All right. We'll take a look into some of that stuff. Also, check out Fancy LED, which runs on CircuitPython, and WLED, which is, by all accounts, and Erin St. Blaine, FirePixie, she uses these types of LED apps a lot. I believe WLED has become her favorite. I think it's a little more recently maintained and updated than Fast LED maybe at this point. It seems like it's friendlier as well, just because it's a more of a web interface for most use. Anyway, let's see. Let's talk about what we're doing here today. So this is the workshop. I continue to add stuff. Oh, before I forget, actually, remind me, and I'll remind myself, but remind me, I want to talk about Pong a little bit. That reminded me right there, because that's a Pong arcade PCB. But remind me to talk about Pong, a Pong event that happened here in Los Angeles. So what we're going to talk about, we're going to talk about that. We're going to talk about discount code, coupon code that I have for you if you want to shop at the Adafruit store. I'm going to talk about a product pick of the week recap. I've got a CircuitPython Parsec for you. Wanted to look around in the Learn Guides. I wanted to talk about the current project, the Power Deliverer, and I also wanted to start in on this thing here, this VT100 and what that's all about. I think that's about the shape of it. And I wanted to talk not only about this project from a microcontroller electronics coding standpoint, but also about the 3D case design that I did for this in Rhino. So I wanted to show you some of the tools behind the scenes there for that. So to start off with, Deliverer, that's your coupon code today. So if you want to head on over to the Adafruit store, this is how we pay for everything we do, pretty much, is selling stuff. And if you want to go buy stuff, awesome. And if you want to save a little bit of money, even awesomer. So Deliverer, that will get you 10% off today in the store. Head on over there, check out some of the new products, check out some of the product categories. It's good on anything you can buy other than gift certificates, software, and subscriptions, and some I think Raspberry Pi devices are immune to discounts. I'm not sure where that fine print is. I said I'd find that out. I need to find that out. But if you head on over here, this is it. This is the Adafruit right here. Where'd mine go? Where'd my browser go? Come back. There it is. That's Adafruit. Look, here's some new stuff. We got these Bus Pirates. I think those are on the discount. If you go to Products and then New Products, View All, you can see what some of the latest stuff is. We have some of these Bus Pirate accessories and the Bus Pirate itself. We have a new breakout here, this reversible Type A USB breakout. So you can plug that in either way, break out the 4 pins, D+, D-, ground, and voltage, and use that in your projects without having to worry about flipping it the right way 3 times. Some new snap fit enclosures here. The Ruiz brothers have been taking some of their 3D print at home designs and having them printed in higher quantities with cool see-through materials and diffuse materials on an SLA printer, or a farm of them off at, I think, JLC PCB or PCBWay. Anyway, these are some of the new products, but you can go and check out the products category drop down here and see if there's anything you like. And if you do see something you like, then don't pay full price. Get 10% off with that coupon code right there. Deliverer, I'll get you 10% off today until midnight East Coast time in the US. Okay, so next up, let's have a look at, this is the show I do on Tuesdays, which is my product pick of the week. I had a new product pick this week, got to do some snazzy little demos with it, give you a deep 50% off discount on it, and do a little demo which I've recapped here, so check it out. It is the Feather RP2040 ADA logger. Got our Feather RP2040 ADA logger, and then connected underneath it I have a battery and I have a accelerometer breakout board. So what I can do is actually take my SD card and pop that into there. Every second this should be writing a piece of data to that card as this little Lego Jeep I have, little Technics Jeep Wrangler, experiences different accelerometer values. Then I can go ahead and reset that and pop out the SD card, put that into my computer over here. A little graph of that data. So over here on the left you can see these are the XYZ accelerometer readings that were coming off of that board. My product pick of the week this week, it is the Feather RP2040 ADA logger with micro SD card and 8 megs of flash. Indeed. And something I mentioned during the show yesterday, and it didn't appear in that demo, but one really neat thing about that ADA logger, it's not just for logging data, it's actually if you want a Feather with micro SD card so that you can put assets on it, such as WAV files, MP3 files, BMPs, sprite sheets, that sort of thing. Great for storing assets because while it is a hefty 8 megs of flash on board, you can put enormous amounts of stuff on a, what's the word for, ejectable SD card, removable, that's the word, removable SD card, swap them in for different project needs as you go. So pretty cool board. Next up, let's dive into this CircuitPython Parsec. All right, let me get set up here. And for the CircuitPython Parsec, today I want to show you how to deal with sensors being unplugged gracefully in your code. So you can see here I have got one of your typical examples of a nice little cutie pie with its STEMMA QT port plugged into a sensor. This is the VICNUL 4040. It's a proximity sensor. And what I'll do is connect to it. That's the cutie pie, so Disco Tool Cutie. And I can reset that there. So here you can see in the REPL, with it plugged in, it's just chugging along doing its thing, reporting to me lux values and proximity values as I move further and closer to the sensor. Now, this all presumes that everything is plugged in properly, which is great if you're in control of the whole gizmo, the whole device. But sometimes if you have things that are sort of customer facing, client facing, someone else is the user, things can get unplugged. Now normally that will cause a crash in your code, but you can see here I've actually got a message showing up that says, hey, plug in the sensor and reset. So now we've got a little nice message instead of just some scary OS error. So I can plug that back in, press reset on the board, and off I go. If you have a little display of some kind like an OLED or TFT, you can write the instructions there. And in fact, in a second, I'll show you another example of that. And the way this works is in my code, when I run my usual loop, instead of just saying while true, I'm saying while plugged. So while this variable named plugged is true, then we're going to try to do the thing I want to do, which is print out the proximity, print out the light value. These right here presume that the sensor is plugged in. If that's all good, then plugged stays true. However, if we run into an OS error, which is what's happening under the hood if that gets unplugged, we're going to print this little message that says, hey, plug in the sensor and reset it, and then we're going to set this value to false. So now while we're not plugged in, we just pass, we just hold on to that. So here's an example with a screen that I like to show, which I think makes a little more sense, but the code is more involved. So I'm going to plug in my power deliverer here, and you can see if I go and try to do something with the power plugged in, it works. But if I unplug USB-C power, now one of my I2C gizmos is going to fail. It's essentially not powering that gizmo. So if I go and try to say, hey, use the gizmo, it says, hey, replug USB-C. So now I can go ahead, replug that, and it's back in business. So that is how you can gracefully fail when an I2C device gets unplugged inside of your code. And that is your CircuitPython Parsec. CircuitPython Parsec. All right, so hopefully that's useful, the little mini code example. One thing I'll say about it, let me unplug this one and plug it back in, is that you would also want to potentially run that same logic up at the top here when we first are checking for I2C. So right here, I2C is board stem I2C. The sensor is this sensor that's expected to be on I2C. You can actually wrap all of that up inside of the same sort of try except, so that if it's not plugged in when it starts, you'll get an error. In fact, let me show you that in action. So I'll reset my board, unplug I2C, allow it to restart, and if you watch in the REPL here, it's going to say, hey, we got a runtime error. There's no pull-up found on SDA or SCL. Check your wiring. Okay, that one's actually pretty, that's a nice error. That's actually pretty helpful. It's not as nice as some of the errors you'll get once it's up and running and the device gets unplugged. But if you wanted to, again, have this go out as a nice graphical message on your display rather than cutting out to the REPL, you would wrap this up in the same sort of logic and then be able to say, if we fail at getting the I2C bus in the first place, print a nice message, don't just crash out. So this is useful when you're making devices that you're maybe not the end user for, or you just want to be kind to yourself, is to wrap things up in some nicer logic to deal with some of these conditions that can occur. Okay, so let me unplug that there, and I'll set this off to the side. By the way, this is evidence that this was a sensor I did way back in the early days of product pick of the week, because I had my little hang board there and I was 3D printing these little Stemma QT hangers. So that one's still sporting that cute little 3D printed hanger on there. All right, so let's see. Before I forget, Pong. So what's going on with Pong? Let me jump over to a browser window here. And this is mostly of interest if you're in the Los Angeles area or you're going to visit Los Angeles. There is an exhibit at a space over in Pasadena. It's a space called the Eisenberg Space. And there's an exhibit right now called Avoid Missing Ball that is all about Pong. That's right, the Pong video game. So curated by Supercade, who is Van Burnham right here in this nice 3D printed, or dot matrix printer image there. This is what the space looks like. So you can see there is a really old Pong machine, original Pong machine in the corner there, beautifully restored. And then on this middle table, there are tons of the different consumer Pongs, as well as some interesting clones, variations. There's one from the Soviet Union that's running on a CCAM television that they got up and running. Very neat exhibit. Just look, Google for it online. You'll find videos and images that people have posted of it. But it's all about the history of Pong. We were lucky to go on last Saturday when Al Alcorn went and talked about his experiences developing both Pong and Atari itself, so that was pretty cool. There may be video of that available online. And the thing I forgot to do was bring my Pong PCB. This is actually Pong Doubles PCB. I should have brought it and gotten Al to sign it, but I forgot. But this is a Pong PCB that I have, and I've never tried to get it up and running, but I'm gonna take a look at making a little edge connection harness there to plug that into a monitor and get some buttons and power to it. So who knows? It looks to be in good shape, but it is anyone's guess if that thing actually wants to run. So I'm gonna do a little testing on it before I blow it up. But that is a Pong Doubles, and if I get that project underway, I'll share progress on that as I go. I think the only Pong that I have easily available right here, right now, is that little keychain Pong. Kind of terrible. You can only play one player. But I do have my Atari 2600, my original one, somewhere, and it's got paddles for it. I need to get a Pong cartridge for that. I don't think I actually have one. Which is kind of weird to think of having an Atari and some paddles, but not Pong itself. So Todd just posted, thank you Todd, Todd just posted a link over in the Discord if you want to click that and check it out, and then Google around to find out more, and maybe express some interest and see if they'll bring that exhibit to a city near you. Right now I think it's just planned for a limited time, next few weeks, in Los Angeles. If you're in the area, come and check it out. I believe also that Supercade is working on building a video game museum here in LA. They've had a small private one for a while, but they lost their space that they had, so now they're talking about starting up a new one. And I believe there's going to be another related exhibit coming up. I'm not sure the date, but it is involving Microsoft Flight Simulator. So I think there's a Microsoft angle on some of the sponsorship here, and I think there's going to be a Microsoft exhibit. So you can follow Supercade. I think it's Supercade21 on Instagram, or Google Supercade to find out more of what's going on there. And maybe I will put together some of the photos that I took from the trip and show them on the show next time if people are interested. And yeah, Toddbot went. I met up with him there, and we did get to play some pretty intense doubles Pong on the couch there in front of the big TV. That was a version on the Atari cartridge, 2600 cartridge, that had two paddles that move together on each side, so you can play net play, which goes nutty. A lot of fun. Abadus says, imagine if you fired it up and realized it's just Space Invaders. Yeah, there are clues that this one is Pong, but certainly there are cases where things are not actually what they're marked as. I think these are all transistor logic on these. There's no microcontrollers or anything like that on those early boards. But there you have it. So that's the Pong segment. Go check it out. All right. Next up, let's talk about this gizmo right here. I'm gonna unplug everything and show you what I've made. I think I'll leave it here so I can show on the little down shooter here and leave the VT100 on the bigger one. So this I showed on CircuitPython Day. You'll recognize it from that. That is the 2x10 swirly grid. And on top, you can see I've got a little cutout for my screen, and I love this technique that the Ruiz brothers have been using a lot, which is to create little living hinge style button pressers. So the little tactile buttons that are built into that Feather ESP32S2 reverse Feather are just right under there, and you can click them without needing like separate parts, tiny little separate parts that are a pain to print and need to be trapped in there. So that's just an aspect of, in fact, let me show that up real close on the down shooter, because I think these are neat. Let's go to that view and give me a moment to focus that a little better. So you can see, hold this, click, 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 and there's the reset. So I'll pull this apart. You can see I've just made like a little channel here that this snaps into. Unfortunately, this swirly grid is a little bent because I think I did a demo at one point of how you can bend these into, different shapes for your projects, and I realized that was my last one, so I had to unbend it. But what I'll do is, let me get a little tool and pull that out of there. So I've got USB-C here for the power delivery on the back. I've got USB-C on the side for the Feather. And then I've got the hole for the DC plug here. So this kind of wiggles out, fits in there. So it's just a single print, which I like to keep it simple. And there it is on the swirly grid. We've got the Feather. We've got the INA 219, which is a high side current sensor. That'll sense the current that's being used. And then this is the power delivery dummy. Now I'm actually going to switch this out before I publish the guide for the other version that we have. This is the fancy version of the HUSB 238 power delivery dummy. I don't need the switches on here for it, but I do like that you can power it with or you can plug into it over I2C using a Stemma QT connector. This one is the lower cost one, doesn't have that, so there was some soldering involved, but I realized if I go with this one instead, this can be pretty much a no solder project. You'll just plug two I2C things in and be done. And I like that. I think that may also eliminate the this board going down when USB-C, because right now it's powered over USB-C as well as doing all the USB-C stuff. So I'll probably be able to simplify the code a little bit with that. So anyway, that'll be an option. You could use either one. I think this will still work in the same case. That's the same height. Yeah, I think that'll work fine without redesigning the 3D case. I did do a version originally that had some cutouts for those terminals, but I realized I could just lower them, put them on shorter standoffs, and then get rid of that. Again, simplify things. There was no reason to have access to those for this. So let's go ahead and, I guess I'll leave it open here and show you it in action. Somebody says aluminum doesn't like to bend twice. This is true. It's just a little warpy here. At least somehow didn't split and break yet, but yeah, it's probably fatigued. So here's how this works. I've got a power delivery hub. This is the kind of key to the whole thing. So this is a Anchor, a nice one. I'm going to link to this in the guide. So this one offers a huge amount of current. It's got like 5 different voltages it can do, and it has 3 outputs. I think 2 of them, I think both of these can do power delivery, the USB-C ones. This one may be higher current available. I'm not sure. They put a little laptop icon on that one and a little phone icon on that one. It may just be that that's when they're both plugged in that this one can handle more. But it also has USB-A, which is great because I just want to power this cutie pie over, or this feather over here, without having to make my own voltage step-down conversion, because we do not want to send 20 volts over to the feather, so we can't just run it off of one USB-C that's headed here and out. So anyway, this is a simple way to do it, and this is a nice one to have because you got multiple ports on it. So if I plug that in, that by default is just going to provide 5 volts over everything, unless the device on the other end, in this case the HUSB 238, negotiates for a higher voltage. So if I plug that in right now, you can see the message on there. Can you? Boy, that's a really hard, high contrast thing to read over the camera. It's a little easier in real life. It says, plug in USB-C PD cable, press reset. So again, using that same concept that I showed in the CircuitPython Parsec, right now it knows that this device wasn't available on startup, so we've got to reset to get that device available. I believe that, like I said, that problem will go away if I'm powering. This one can't be powered over the I2C. It only powers over the USB-C. That other one, I believe, can, so we'll see. So I'll plug in my USB-C here and press reset. And it will default to 5 volts. That's what it's going to give right now. And it's sending 5 volts over here. I've got the high side current sensor there, so I'm going to plug in a LED strip. So this is this blue neon LED strip. I'll plug this in over here. And this doesn't want 5, this wants 9. So I'm going to press the up arrow and turn that on. I also, just for convenience, have a inline DC switch over here. So we've got 9 volts, and then I can see here it's drawing 85 milliamps. If I go up to 12 volts, which is actually what these are meant to run at, should draw more current, should get brighter. There we go, we're at 12 volts, drawing about 300 milliamps. Set that back down to 9. I don't know if there's a problem providing it 5 volts. It might not love that, so I'm not going to do it. I'm just going to turn it off here, and then you can see I can send out anything here safely because I've just turned off the physical power switch to the gizmo. So I can run different things, like, if I still have the right cable, this fan, right? So here's a little solder sucker fan, solder fume extractor fan, I should say. And I've got a DC barrel connector there. I can plug that in. This one happens to be the same size as the one I'm using on the LEDs, and I'm leaving this at kind of that standard, I forget, 5.1 millimeter, 5.5 millimeter. But like I mentioned on CircuitPython Day, you can get a really complete set of adapters that we sell in the Adafruit store, so that you can contend with all sorts of weird sizes of DC stuff. One thing I'm not addressing is I'm keeping it center positive. You could simply swap that on the output to your cable if you wanted to go center negative. Or you could use, we have a little reverser cable, just mark it really well, like put pink tape on it or something so you know that it's the center negative. And then you can still use those same adapters there. So let's see, 1 second. So if I go ahead and plug this fan in now, it's blowing and it's running at 15 volts. I could probably put an eraser end of a pencil in here and try to slow down the fan and get that current to go up. So there you go, it's stalling out and going up to 300 milliamps. It's a bad idea, but so this one will actually, I don't know what it's rated for. What does it say in there? 12 volts. Fan happens to not mind too much going up to 20. gets real fast. Whee! Drop that back down because it's probably not the best thing for it. That's actually what it's supposed to run at, is 12. And this will actually continue to operate even at 5 volts. I get that fan turning there. Not that you can see or hear it, but it is a gentle breeze on there. So I can go ahead and unplug the power there. Now with that code that I was showing before, if I unplug this, it's actually not, there's no active checks. I could maybe add an occasional check for the thing's sign of life or something like that, but right now I only really query it when I do something with the button. So if I try right now to set it with the 0 button on the feather, then again it says, hey, replug USB-C, because we can't really do anything while this thing isn't getting power. So give it power back, and it comes back to life here. Set it back to 5 volts. Current sensor just chugging along doing its thing. So that is the state of it. If I go ahead and unplug it, put it back in the little case here. And that just snaps in, and it's ready to go. So you can see all of that in action. There we go. And now it's just nice and neatly embedded in this candy bar kind of case here. There we go. Reset it, so all those buttons are available. And this helps a little bit with the display as well. A lot of those displays have just a little adhesive under them. They like to flop off of the feather, so this kind of keeps that sandwiched neatly inside here. So let me know if you have any questions about that there, and I'll keep an eye out for those. Tyeth says, what did you create the case using, and were there any issues you experienced or were new to you? Thank you. That's a great question, a good lead-in. So first thing was, here was the first version I made. Whoops. I just hit F11 and all my windows disappeared. So here was the first version I made, and you can see I had longer standoffs, standing those two I2C boards off of the swirly grid, so I needed to make some room for them. I also made a little hole for seeing the LED lit on there. I realized I didn't need that, and I could lower those onto shorter little, I think they're 6 millimeter instead of 8 or 10. So I dropped those down in height, and that meant that they actually cleared these right here. These little screw terminals had to pop up and out. They could drop down and just be low enough that I can still use the same height for the thing to be able to click my little buttons on the feather there. So that was the first step. I also realized I didn't need as much clearance for USB-C to plug in, so I could kind of seal up the tops here and go with some smaller, you could see I could go even smaller than that, but this will accommodate most any USB-C cables that I have there. So those are kind of the main issues that I ran into, but it's a great segue, Tyeth, because I wanted to show you how I built it inside of Rhino. So I'm going to switch over to Rhino here. If you're not familiar with Rhino, it is a CAD software that's been around for about, oh gosh, I started using it in its beta back in like 1998 or so it's been around a long time. Originally, it was billed as being a NURBS modeler, which is a certain type of 3D model construction technique that up until that point was pretty well relegated to Unix and really IRIX SGI machines. I was using a piece of software called Alias and Alias Power Animator, which were kind of the only ways to get your hands on NURBS modeling, which was, you know, $50,000 for the software, $80,000 for the computer. So these guys came along and essentially licensed the same underlying NURBS libraries that were being used in the IRIX world and made it for Windows NT originally. Eventually, at one point, it also came out on Mac, and I'm using it on Mac here. So it's evolved a lot. It's a solid modeler. It's got subdivision surfaces now. It's still got great NURBS tools. And the real important part was that at some point they created or acquired and integrated a parametric modeling interface called Grasshopper. So that's what you see here in this little slider thing, is a little parametric gizmo that I built to make the swirly grids. So this was my kind of first step, was I wanted to accurately make swirly grids and then build the rest of the model around that. So this, I'll just show you this demo here, is my parametric swirly grid builder. So I can make the one that you see here by going to 10 units, 10 swirls wide and 2 swirls high. I can also build our full, that's our biggest one, a 10 by 10. We have a 10 by 5, not 6, 10 by 5, and we also have a 5 by 5. So those are the ones that we make, but since I could laser cut or 3D print or send off for an aluminum PCB like we do for the Adafruit ones, I could kind of make unique sizes with these. And it doesn't have to be limited to these sliders. This is just what I built right now, but a little bit about how Grasshopper here works. It essentially is a node-based workflow that allows me to take data and run it through different operations and then output geometry that I can use for the model. So, 1 second. Sorry, just got distracted there for a second. So the little gizmos that I'm using right here are just these number sliders. I can go in and edit one of those and say, okay, let's see, can you see that? Oh, darn, no, you're not going to see pop-ups. Okay, I'm just going to change this one right now to say we can go up to a maximum of 20. So now I can make really, really wide swirly grids here and print those out. The way this is built is I've hidden a lot of the complexity by encapsulating a bunch of nodes that I built into one, what they call a cluster, but it's sort of a shareable little component that I can just make minimal interface for and give that to someone else, or make it easier for me to deal without looking at all this mess. But what's really happening under the hood in this case is I am starting with a little curve that I just drafted that's based on one segment of our swirly grids. So you can see that right here. If I turn this on, you'll see. So there's the, based on Scott and Jeff Epler's Python script that they use for KiCad. I just looked at that script and grabbed some of the values from there so that I'm working in the same units there and then doing conversions. Theirs is based on like a 0.6 inch diameter hole, I think, or maybe that's the slot height. Anyway, the numbers are all there. So I just grabbed the numbers from there and built one of these things. And then I have that sort of embedded in the file. And then everything else is based on saying, okay, take one of those and offset it by a certain amount that the slider says at a certain distance. I also create, let's see, can I show? Yeah, you can see I've got some linear dimensions. Let me go to a perspective view. My curves are showing up very fat on this, so you can see them, but it's kind of burying. This is in millimeters, the width of the full thing. And I'm gonna show you, here's the sort of parametrically built edge of the thing with the proper radius. So again, if I start sliding the size of it, you'll see that change. Here is the part of this that is all of the little holes. So this is just the little curve maker. And then, let me see if I can, yeah, I'll just summarize this part because I don't want to do too much of in-depth on Grasshopper and Rhino. But in my full file, what I do is I then extrude solids and cut them out. So I make the bottom plate be a little sort of flat rectangle or box, and then I carve out anywhere where those holes are. Very similar to how a thing like this gets milled. So that's the starting point, and then I actually imported the, thankfully I didn't have to just measure this stuff. There's great CAD models that the Ruiz brothers have made of things like the feather and a lot of our sensor boards. So I brought those in and just aligned them properly, and then I don't have to do a whole bunch of caliper measurements of things. I can just align the cutouts for the holes for my little button pressers and things like that, the window for the display, and actually all just work. Because we've already got these great models that they've built. So I was able to bring in those, make my little cutouts with those measurements there, or just visually, and then output that case. So let me see if I can open, I might have to reshare a window after I do this. Let me see, I'm gonna close Grasshopper here and open, let's go back out one menu. Sure, yeah, let me open this. Okay, I'm just going to copy that and paste it into this file. There we go. That'll make it easier as far as screen share goes. So here is the file that comes out of that. It's not aligned just because these are separate spaces I was working in, but here is that outer curve that I made with the swirly grid. I have it sort of parametrically offsetting a couple times out and one time in so that I can then extrude the little sort of cutout channel where the grid goes. I made a little lip here for it to snap into. Most of this is just a Boolean subtraction or a solid difference between models to cut out spaces for the holes to go. I did no chamfering, no extra chamfering of edges. I could do that to make it a little softer at the top here. Take an edge like this and run a little chamfer or fillet around it just to round that edge out like you see on the sides here. So that's it. That's what I put together. And then I exported this as a STL file, which is a triangulated mesh with enough density to capture all of the details that I want to be able to then go 3D print. Put that into a slicer. I used Cura and flipped it upside down. This gets printed like that. Oh, you know what? This one I think renders nicely. Let's see. This machine has got decent horsepower for rendering. It's a lot clearer to look at. So that's what it looks like on the 3D printer bed, and there's very few overhangs other than this stuff here, which it actually handles pretty well. These aren't very big, but it still manages to snap in there and catch it well. And we're pressing down on it, and the top of the aluminum is resting in this little channel here, so it stays pretty nicely. Yeah, one funny thing I've noticed over the years is that you don't have to go in and fillet or chamfer every edge necessarily, because 3D printing already kind of does it for you. There's a little bit of rounding of things. So if you were manufacturing this thing by milling it out of aluminum, you would probably hate this edge. It would be painful or dangerous to leave that hard. But for 3D printed stuff, you can actually get away without having to go in and do it, and it just makes it a little faster to get to your end result, a little simpler. Yeah, that said, for aesthetic reasons, I love it. I might go back in there and round some of that stuff out. So that would look like this. Let's flip it back upside down, and in here I can just say fillet edge. Pick this edge here, and we'll give it like a 2 millimeter chamfer. Or will we? There we go. Whoa, that's too big. It won't allow it. It ran into stuff. Let's try that again. About 1 millimeter. Oh, it's failing for some reason. All right. Huh. Don't know why. I can deal with that later. Sorry about that. Yes, so that's the process of making the case. And that'll be, I'll probably just put the STL file and a step file, which is this sort of NURBS geometry low res, or I should say, it's not that it's low resolution, it's more like a vector graphic versus a raster. It's actually got kind of infinite resolution to it, but it stores it in a simple way. So this is a sort of a more mathematically described surface versus a huge ton of small triangles, which is what you get when you go to turn that into an STL file. You get something like that. Obviously, I need a lot more. It'll look goofy like that, but you can make really dense files that are good for printing, but they're actually not that much fun to go and edit later. So I'll probably put out that step file, which is a little easier to edit if you need to. Some Nice had a couple of comments. One, everything in 3D got bought by Autodesk. Yeah, so I was talking about Alias and Power Animator, which became Maya. All that stuff got bought by Autodesk. Same with 3D Studio Max. That was someone else, got bought by Autodesk. He mentions Blender, which is a great open source 3D and Some Nice's favorite. Yeah, I'm not saying go and buy expensive CAD software. I think student versions you can get a pretty cheap of Rhino, and they actually let you use it for commercial use if you're the only person using it. So if you are a student or a teacher, you could look into Rhino. It's a great tool, and once you add Grasshopper onto it, it's just tremendous. That said, most anything anyone can do in any 3D software, someone has probably written a way to do it in Blender. So that can be a really good way to get started in, or never leave it if you don't want to. Okay, so if there's not any other questions, let's see. Dave Odessa says Rhino looks very complicated. It has complexity for sure. I think any fully featured 3D application is pretty complicated, but yeah, it's not something like Tinkercad where there's just a few things you can do and it does them well, but it's specific to a very simple workflow. Also, I should say Rhino is on its own not too complicated. You can do things like draw things and extrude them, and you can do all that in the interface. You don't have to use stuff like Grasshopper to do it, but Grasshopper gives you that ability to go back and change things with sliders and numbers and formulas and things. So it's a different ball of wax once you get into parametric stuff like that. Let's see, other questions? No? Okay, so let's then move on to our retro find of the day, which is that gizmo right there. Oh no, this camera, oh my gosh, it's not even that hot in here, and this camera is conked out over here. Turn that back on. I'm just gonna cool it off a bit. Let's see. Okay, that's back on? Yeah? Yeah. Okay, so let's go over here. And I'll go to that small bench cam. So that right there is my latest curb find. I found that on the street. It's a DEC, Digital Equipment Corporation, DEC VT100, which is a video terminal that was meant to basically allow you to interface a keyboard and a screen with a mainframe computer or mini computer that didn't have that kind of interface. So this is a terminal, just like you're used to things like a terminal shell on your computer now, except that's all it did. It's based on an Intel 8080 processor. I'm in the process of trying to source a keyboard for it. There's also a project out there for taking a USB keyboard and converting it using an Arduino and a shield and something else into the standard that this thing accepts. It's got a nice little, I think it's 13-inch mono display, CRT display in there. And it has expansion space in it for different cards. It has one video card in there right now. If you look on the back, you can see that gives us video in, video out, keyboard in, and communications. So there's a RS-232 25 pin, I think, connector on there. And then everything else we're looking at, excuse me, this is the power switch. This is the fuse to the power supply, which I blew. You can see it exploded that fuse, so there's something wrong in the power supply that I've got to start to diagnose. This is on-off switch here. This is a switching power supply. It's set to 115. It can go to 220, I think, in 115. And then AC power for US. Curb, what street do you live on? Yeah, I couldn't believe it. I mean, I have my senses attuned to TVs because I'm always finding, like that one there. I found that big TV back there. That one I just found on a curb as well. So I'm always looking for TV-shaped things, CRT-shaped things, but this one was kind of astonishing to find. You can see here it was property of USC. Someone had just put it out on their curb, and it doesn't rain that much here in Southern California, so it was not damp inside. I lucked out there as well. This has little clips that you pop, and then you can lift off the shell. Has a little soot and dirt in there, which could be a bad sign or it could just be typical, not sure. Nothing else has scorch marks on it, which is a good sign. And you can see it's just a whole lot of room, right? We've got power supply here. This is where our cards live. And in fact, I think I'll take this shell here off this outside of the case so that we can take a look at the card edge section there. Let me get, it's just a flathead, should work. The plastic seems to be in decent shape. I wouldn't be surprised if it's brittle, but there's actually no cracks that I can see, knock wood. This is actually, not a lot on here uses screws. Most things have these little pull tab toggle things, which is interesting. So I don't know if those are replaceable if you lose or break one, which is the one worry with semi-weird connectors. But this is, let's see. We'll see if this just pops off. I think it should. I think these screws stay in this plastic case actually, which is good. Again, less opportunity to lose them. So this was manufactured in October of '81, it says, in Albuquerque. So they were based in, DEC was based in Cambridge, I think, and they had a manufacturing plant in Westfield, Massachusetts, I believe. This one being pretty much a West Coast machine, came from this Albuquerque plant. And what else? It's the model VT100AA. I know, I see that designation. I'm not sure what other ones exist and what their deal is. You can see from this some of the substantial yellowing. There's the original color. There's the yellowing. Could be worth doing a retro bright pass, which is a method for removing the, I think it's a fire retardant in the plastic that leaches up to the surface and yellows over time. So here we can see all of those outputs that I looked at are on this one card. So this is the main board, and then there's connectors to add on other add-ons, and there's space in here you can see to add other add-ons. This, I think, is all the driver. Be careful in this stuff. I haven't shorted out the monitor. Don't go picking around in these if you haven't before. This should be shorted with a. I have a tool for that to short the tube, the cathode tube, because it's could be carrying a ton of voltage, so this is dangerous. No caps on the driver board there look like leaking or exploding or bulging, which is good. The power supply, some of the options on that will be to remove it, give it a once-over, look particularly for some capacitors that are shot. Other option, I don't like it as much, but there are some pretty good plans out on the internet for schematics and boards for converting an ATX power supply, your kind of typical modern computer power supply, to run on this, including a, I think, negative 24 volt rail that it needs, and then it might have like a 12 and a positive and negative 12 and a 5, but I think it's got one that's a little odd on there. So that's another possibility if that power supply itself can't be rescued. But yeah, a lot of these little plugs get pulled out and then lifted out, so I'll probably do some of that. Let me see if we can dig into the card that's in there. Let me go to this overhead view for a second, see if we can see. Yeah, there's not a lot of light in there, but if you look at, let me see if I can point a light. All right, I'm grabbing a very big, bright light here to try to all right, so spotlight is being used here. The see that second board there? The one that disappears when I go like that? So that's a smaller little board in there. That could just be the, I think, 40 column text, or it might be more advanced add-on board. I'm not sure, but there are 80 and I think even 120 character add-ons. I'm not an expert in this, so I could be getting those wrong, but that one may just be the sort of default one, and then there are add-ons that can slot in here to give you other capabilities. There's also printer add-on cards so that you could print, and I think some others. There was a big light, it's true. So let's zoom out here. Is there anything interesting to see? Not so much. I hear just a little bit of crumbled plastic. So the driver board here for the video display has cracked off of its little standoffs. Nothing looks shorted, but I'll probably replace these little plastic clips that this is meant to be clipped to the frame there with. And hopefully the flyback transformer is good, because that's going to be one of the hardest things to acquire a replacement without just getting a partly working one that's broken in different ways. The option is to do video output from here, but that's totally lame. But you could go out to another display, like one of my little PVMs, or even a black and white TV through a converter. So you can get whatever it's sending out to an external display right here. You don't have to dig around on board if there's a problem with that display, or if you wanted a second monitor for some reason. I think that's possible. And that is it. That display. So if you've ever dealt with any terminal software, VT100 is emulation mode you'll see because it became kind of a standard. It was just the name of their device, but that name came to mean their set of ANSI escape codes, Control G for Bell, some of the other standards that you'll see inside of your modern software that's acting as a terminal. A lot of it originated here with this beautiful guy. Obviously, there's a ton of space in there, so there's, I'm sure, plenty of projects out there where people have just put their own other electronics in there. It's probably not, I'm guessing, not too difficult to get a Raspberry Pi writing out over composite video onto there, like I've done with some of my retro projects. So could be one of the retroest of the retro projects right there. DEC Digital VT100. You can see there was a sticker on here that I removed. Return Shift ND, someone penciled in on there. There are some sticky rubber feet that got stuck to the top. I'm not sure what was on there. I've heard some people online complain that when they get one, the keyboard was living on top of it, and the feet from that, kind of the gooey rubber, dissolved onto them and got stuck. I don't think that's what it is in this case, but someone mounted something to the front there, or to the top, I should say. Andy Callaway says, some of the later VT100s had nice paper white screens. Yeah, I'm curious what, I think there are, I see blue tinted ones a lot. I don't know what this one's going to be. Abadus says, I'm surprised there isn't a post-it note with a screen, a post-it note with a password on there. Yeah. Who knows what it was used for? That's the thing. It's a mystery. It was logging into something else. It doesn't really do much on its own. So what was it connected to? I've also read about there were people who made probably bought them on some sort of like OEM level from DEC and then made them more purpose-built, and some of them did put some compute power in them, so you could buy them as some sort of a standalone thing. But you would find these in airline reservation systems, universities where people are talking to mainframes, libraries. These were, yeah, a password's a password, says Andy. Yep, for sure. Okay, so that's it. That's what I've got going on today. Thanks for stopping by and hanging out. Toddbot is quoting the password from War Games, pencil. I wonder if that was on a VT100. What was the computer that he hacks into it or walks up to at school to change his grades? That's a good question. So that, where'd it go? There we go. That's the password. That's today's password. That's today's coupon code. If you want to head over to Adafruit, buy yourself some cool stuff, go do it. I'll be working on writing up the Learn guide for this gizmo right here. See if I can swap in the other power delivery hub dummy thing. And then I've got some other projects in the works coming on up after that. Don't know if Scott is doing a deep dive tomorrow. Check our blogs and our Discords to see what's happening, but usually we've got some Foamy Guy and or Scott doing deep dives Fridays, Saturdays. There's probably a desk of Lady Ada in the works somewhere along there, and then we'll be back on Tuesday with another product pick of the week, Wednesday with 3D Hangouts, show and tell, ask an engineer, much more. So come on by and hang out. Whew, that's it. Thanks everyone so much for stopping by. This has been John Park's Workshop. I'm John Park. I will see you next time. Bye-bye.
Thank you.